Okay, one other type of redox reaction is combustion. So we have combustion when we burn some sort of compound in oxygen. Most combustion reactions are done with hydrocarbons or with alcohols. So typically our products are going to be carbon dioxide and water vapor. Because these also undergo electron transfer, they are also classified as redox reactions. Okay, so here are a few examples for us to look at. We've got an alcohol, and then I have a couple of different hydrocarbons for you. All right, so I'm going to take all right, and then this is going to be a liquid. We're going to burn it in our oxygen, and we're going to get our carbon dioxide and our water. Usually combustion is done at a high temperature, so I'm going to put our water as water vapor. Okay, we've looked at this reaction one other time, so we get a 2 there, a 9 there, an 8 there, or a 6 there, and an 8 there. Okay. All right, now let's look at our next one. CH4 is methane. We'll get our carbon dioxide and our water vapor. Okay, now one thing about combustion reactions is that this oxygen right here needs to be paid close attention to. Because it's an O2, when I only have a hydrocarbon on my reactant side, I can only get an even number of oxygens on my reactant side, because anything times 2 is an even number. When I look at my product side, carbon dioxide, okay, that's got an O2, but water has an oxygen by itself. So when I'm doing combustion of a hydrocarbon, I have to make sure that whatever I put in front of water is an even number. So I have H2O. So I'm going to look at my hydrogens. I have CH4. 4 divided by 2 is 2. 2 is an even number, so I can put a 2 there in front of my H2O, and I'm good, because 2 times 1 is 2, so I have my even number. Okay, so I have 1 carbon, I have 1 carbon. I have 4 hydrogens, I have 4 hydrogens. But now I have 4 oxygens on my product side, but only 2 on my reactant. 4 divided by 2 gives me 2. Okay, our next one. C4H10. Okay, plus my oxygen gas. I get my carbon dioxide. And my water vapor. Okay, now here, H10. Well, what's 10 divided by 2? It's 5. So if I just divided that by 2 and put a 5 here, what would happen? Well, I'd have an odd number of oxygens, and we can't do that. So what I'm going to do instead is I'm going to take that 10 and put it there, and take a 2 and put it there. So 2 times 10 is 20. 10 times 2 is 20. So there's my hydrogens. Okay, now 2 times 4 is 8. So I have 8 carbons. I'm going to put an 8 in front of the carbon dioxide because there's only 1 carbon in carbon dioxide. And so whatever number of carbons I have from my reactant side, that's what I can put in front of the carbon dioxide on my product side. Okay, now it's just a matter of my oxygens. 8 times 2 is 16. 10 times 1 is 10. So that's 36. Or not 36, that's 26. And then 26 divided by 2 is 13. And there's my balance.